Hello, dear students. Today we have Proposition 3 of Book 2. Book 2, Proposition 3. If a straight line be cut at random, then the rectangle contained by the whole and one of the segments is equal to the sum of the rectangles contained by the segments and the square on the aforementioned segment. Okay? So if a rectangle be cut, if a line be cut at random, then the rectangle contained by the whole, and let's take one segment, and one of the segments is equal to the rectangle contained, in this case, the rectangle contained by the segments and the square on the aforementioned segment. That is, remember how we first said the rectangle contained by the whole and one of the segments? That's the segment we mentioned earlier. That's called aforementioned. So let's do that one more time. Here's our given line, cut at random. If we make a rectangle contained by the whole in one segment, that rectangle will be equal to the rectangle contained by the segments and the square on the aforementioned segment. Here's how we kind of say it. The rectangle contained by the whole and one of the segments will be equal to the rectangle contained by the segments and the square on the aforementioned segment. Okay? Let's now, as we always do, let's make our figure. Let's get a square, let's get a rectangle made by this and this. So we'll bring this down to that length here. Let's use black. Drop a perpendicular. We know we can do that. So put our bag of knowledge. What you mean by a rectangle, cutting from the grader. We're not going to use that today. We're going to draw a line parallel. We just dropped a perpendicular. We know what it means to make a square, and then opposite sides of a parallelogram are equal. Okay, so let's do that, and let's go ahead and continue with our nice colors here. Say, I don't know, it's about there. And then continue with the same straight line. Say to there. Okay, and let's drop parallels. We're going to drop a parallel from this point, the cut part of the segment. Okay, and then drop a parallel from the end of the given straight line. Okay, and we're just going to color this stuff in to make it easier for you to see. Okay, so here we have a rectangle, and it's contained. Remember in definition 1, a rectangle is contained by two straight lines and its right angle. Okay, this was drawn at right angles. This and this and this are all parallel. Let's see, we need to, because this was drawn equal to this, and this is equal to this, and opposite sides of a parallelogram are equal, this and this and this are all equal, and they're right angles, opposite sides of a parallelogram, opposite angles of parallelogram are equal. This was right angle, etc. So this is a square, okay? So we want to show that this big old chunk, which is the rectangle contained by the whole line and one of the segments, is equal to the rectangle contained, is equal to this chunk and this chunk, which is the rectangle contained by the two segments, because this equals this, and the square on the aforementioned segment. Okay, basically just did the proper, let's do it. So we got a big rectangle, and we see that this big chunk, this big whole thing, is equal to this chunk and this chunk. Okay, but this big old chunk is the rectangle contained by the whole straight line and one of the segments. Great, so the rectangle contained by the whole straight line and one of the segments is equal to this chunk and this chunk. But this chunk is the rectangle contained by the segments, because this is obviously one of the segments, and here's the other line, but this line is equal to the other segment. So this rectangle is the rectangle contained by the segments. Great. So we got the rectangle contained by the whole and the segment is equal to this chunk and this chunk, and this chunk is equal to the rectangle on the two segments. And this chunk is the square on the aforementioned segment, because there's a square. Okay? So we know that given a straight line and be cut into any number of parts, whatever, the rectangle contained by the whole and one of the segments is equal to the rectangle or rectangles contained by, I don't know if it's just two. Maybe, I think you can do this multiply. I'm not sure. No, this just says two. Is equal to the rectangle contained by the segments and the square on the aforementioned segment. Thank you very much. Bye-bye.